Summer Physics 3-4. This is the day 5 and 6 assignment. It's a brief lesson on parallel circuits. Okay, so here's a situation. Dina and Eduardo work at Vaughn's. And Dina takes 3 minutes to check out a customer. Eduardo's a little bit faster. He takes 1 minute to do so. So let's see how many customers should go into Dina's line and how many should go into Eduardo's line. And your job as the manager is to direct customers to the line that will get them through the fastest. And if the times are equal, we're just going to say that you should put them into Eduardo's line. So your first thought might be, well, Eduardo's faster, just go to Eduardo's line. But let's see how this actually plays out here. So here comes the first customer. Which line are you going to get into, Dina's line or Eduardo's line? Well, of course, you're going to go to Eduardo's line because he's faster. He only takes 1 minute to check out a customer. Next customer comes along. Manager, which line do you send them to? Well, the second customer will take 1 minute plus another minute to get out of Eduardo's line, but would take 3 minutes to get out of Dina's line, so you're still going to send the second customer to Eduardo's line. So now Eduardo has 2 people in line. Now another customer, a third customer comes along. Which line do you send them to? If you send them to Eduardo's line, it's going to take, the third customer will take 1 minute plus 1 minute plus 1 minute, that's 3 minutes, to get out of Eduardo's line, but will also take 3 minutes to get through Dina's line. And since we said if the time is the same, we're going to put them in Eduardo's line, we'll go ahead and send them to Eduardo's line. Fourth customer comes along. Which line? Well, the fourth customer in Eduardo's line will take 1 plus 1 plus 1 plus 1 minutes to get through. That's 4 minutes. But only 3 minutes to get through Dina's line. So you go ahead and send them to Dina's line. So now Dina has 1 person in line. Fifth customer comes along. Put him in Eduardo's line. That fifth customer is the fourth customer in Eduardo's line, so it's 1 plus 1 plus 1 plus 1. That's 4 minutes to get through Eduardo's line. But if you had put that customer in Dina's line, it would have been 3 plus 3. That would have been 6 minutes. That would have taken longer. So we went ahead and put that customer in Eduardo's line. Okay, another customer comes along. Well, the fifth customer, the next customer will take 1 plus 1 plus 1 plus 1 plus 1, 5 minutes to get through Eduardo's line, but 3 plus 3 or 6 minutes to get through Dina's line. So it's still faster to put that next customer into Eduardo's line, so we're going to go ahead and do that. Another customer comes along. If you put that customer in Eduardo's line, it would be the sixth customer in Eduardo's line. That would be a total of 6 minutes. And if you put that customer in Dina's line, it would be 3 plus 3. That would also be 6 minutes, so it's a tie. So we're going to put that customer, we said, in Eduardo's line. So there goes that customer. Another customer comes along. That next customer would take 7 minutes to get through Eduardo's line, but 6 minutes to get through Dina's. So at this point, it's better to send this customer over to Dina's line. Okay, a few more. Another customer. The next customer would take 7 minutes to get through Eduardo's line, but 3 plus 3 plus 3 minutes, or 9 minutes to get through Dina's line, so we're going to send this customer to Eduardo. Next customer would take 8 minutes to get through Eduardo's line and 9 minutes to get through Dina's line, so we're going to send it to Eduardo. Next customer is going to take 9 minutes in Eduardo's and 3 plus 3 plus 3, or 9 minutes in Dina's. So we're going to send this customer, we said, if it's a tie, to Eduardo. Now the next customer would take 10 minutes to get through Eduardo's line, but 3 plus 3 plus 3, or 9 minutes through Dina's, so we're going to send this customer to Dina's line. Okay? So what do you notice about how many customers there are in Eduardo's line versus Dina's line in relation to how long it takes each of them to check out a customer? We see that it takes Dina 3 times as long to check out a customer as it takes Eduardo, 3 minutes to 1 minute. And if you count the customers in Eduardo's line versus Dina's line, there's 3 times as many customers in Eduardo's line as Dina's line. So because Dina takes 3 times longer, Eduardo's going to end up with 3 times as many customers in his line. It's what's called an inverse relationship. It's reversed. Dina's 3 times as long for time. Eduardo's got 3 times as many customers. If it had been 4 minutes for Dina and 1 minute for Eduardo, then you would have ended up with 4 times as many customers in Eduardo's line than in Dina's line. Okay, so how does this relate to circuits? Well, we're going to look at something called parallel circuits. So the point is that since it takes Dina 3 times longer to check out a customer, 3 times as many customers will go through Eduardo's line. Okay, so this is a parallel circuit. So in a parallel circuit, current wants to follow the path that offers least resistance. That is the lowest resistor. And if R2 has 3 times as much resistance as R1, then 3 times as much current will want to go through R1, which has the less resistance. So the 3 ohm resistor is like Dina's line, and the 1 ohm resistor is like Eduardo's line. So let's say we have a certain voltage source, and it's putting out 4 amps of current. And there actually are current sources as opposed to voltage sources, but let's say that we know that 4 amps of current is coming out of that source. So how much of it is going to want to go through R1, and how much of it is going to want to go through R2? Well, 3 amps is going to go down through R1, and 1 amp is going to go down through R2. Again, R2 is 3 times as resistive as R1, therefore 3 times as much current is want to go through the lesser of the 2 resistors. That's the 1 ohm resistor. And so that's really the essence of this lesson. Now what you want to do is follow how the current is going to come around. 4 amps comes out of the source there. 3 of it goes down R1, 1 of it goes down R2. Then the one that goes down through R2 comes back around the bottom, and it's going to meet up with the 3 amps that comes through R1. And those two, when they meet up, will add up to 4 amps again. Okay? So it's like 3 friends are walking down the street. 3 of them decide to go down Highland Avenue. 1 of them decides to continue on and continue along Orange Avenue, and the ones that went down Highland go around the block and meet up again with the friend that went down Orange Avenue. And so you had 4 at first, and then you had 1 go one way, 3 go the other, and then they get back together and you have the 4 friends walking together again. Okay, and that's kind of what's going on here. So this is the way a parallel circuit works. So a parallel circuit is technically any circuit that's not in series. You notice that none of the current that goes through R1 goes through R2. It's different. They either go one way or the other. They don't go both. And none of the current that goes through R2 goes through R1. So that's called a parallel circuit. The resistors are effectively side by side with each other. And that takes care of this brief lesson on parallel circuits. They can be a little more complicated than this, but in this short summer course, we're not going to make them any more complicated than that. So that's the definition of a parallel circuit.